Hi guys. First of all, huge apology for last night. I totally forgot about Will Duffy's the final debate. So that stream was cut off a few seconds before it should start. So sorry about that. Probably will happen again sometime in the future, because the bigger channels are streaming every now and then. Yeah. And guess what? There's still no emails in my inbox about any brave flat earthers who would show us wrong. Let me update. Nope. There is none. Before we start anything, I should ask you, it seems like Real Cygnus, Clive and George, you are the ones who have been here the most. I like to have that intro, as I saw, but as I've seen in many other channels, they start the intro when the stream should start at that time, and then it goes 2 or 3 4 minutes over. Like, I'm not going to say wrong, but when you have the starting time and you have a long intro in the time that you should have streaming, I don't like that. So my intro starts up until 5 minutes before it should start, and then we start at the time. Does that work for you, or should I just cut it out? I like to have an intro. Yeah, the scared of lovers. Bjørn, god kveld eller god natt. Hallaisen. Yeah, here we go again. So I had 2 plans, 1 plan and 1 backup. The first one was again trying to get onto Omnicore. Isn't that what it's called? Omnitalk. But there's just no one there. Nothing happens. So away with Discord. I found either 3 smaller videos or 1 bigger one, again on Ficat's side, because he's a lot of fun. Clive, don't jinx it. Either bottom-up obstruction and Simon Dan with the level and MC2 with triangles, or these 3, or flat versus globe debate cut, who had a strong argument. Should we take 3 shorter or 1 long while we're waiting for the flat earthers to send me an email? Because that surely will happen today, won't it? So any suggestions from you guys? Either the 3 short one or 1 long one. I think it's about 20-35 minutes or close to an hour. If anyone who want to attack, just throw me some suggestions. Short ones. Clive have spoken. Yeah. So I guess we're taking them in wrong order that they are posted, or we can start with Celestial, that one. And as I have said before, I have never seen one of this, so it's going to be a first for me too. Before we start though, I've done this now for 2 weeks ago and this weekend, and probably will do the same again in probably a couple of weeks on a bit more regular basis. I can't tell for sure, but I will try. And I will make some thumbnails and some other videos to try to get some flat earthers on, because that's what I really want to do. Have some flat earthers show us something for once. But I guess we are fresh out of flatties. So yeah, let's see what he spelled his name wrong. Should be a K there. Catsoid. Hi, bring in the derp. Sorry guys, if you're here to just spend some time, I guess this might be the worst way to do it. Oof.
Can I bring up some of those
So that you can
citations
cherry
for
pick?
you?
Sure, sure.
Oh, citations to present to MC Toon. Before we start with that, I guess all the citations will contradict whatever Fiketsoid is saying.
Sure. Cherry pick
Cherry
away.
pick. It's not cherry picking. It's just simply.
Oh, you're totally gonna cherry pick. I mean, we all know it. We all know you're gonna cherry pick. But
As I said before, I see this sound bars are bouncing on OBS, but you can hear that, right? So let me know if there's sound or not.
go ahead.
Okay, let me just pick up some of them, quickly open them for you. There's no cherry picking, but okay. Because you clearly say there's no trigonomic.
For those of you, thank you, have been around for a while. Marcus Dresden. He usually have some flat that are stupid with lots of stars and stuff. So just for the fun of it. I haven't seen around for a while. And of course, they've been hidden by PJ. Because you can't have fun in the chats. That's for sure. Let me see if that 23 seconds in.
Can I bring up?
No, it's gone already.
Clearly say there's no trigonomic function for celestial navigation, correct?
No, I said there's no triangles. So
What
try to
is-
keep it correct.
What
There's
is?
no triangles in
So what's
celestial
what's
navigation.
trigonometry?
Trigonometry is more than just triangles.
What's trigonometry?
You don't know that?
What's trigonometry?
What is trigonometry?
May pop up on
You don't
the
know it?
screen.
Why are you trying to tell me what trigonometry is if you don't know what it is?
You're saying it's not triangles, so I want to know what's Sekatoa.
I said it's not just triangles.
Is Sekatoa triangle?
SOHCAHTOA is, but there's more to trigonometry than SOHCAHTOA.
1, 2, 3, 4, 5, 6. 1, 2, 3.
Oh, did he count?
There's more to trigonometry than SOHCAHTOA.
1, 2, 3, 4, 5, 6. 1, 2, 3.
He can count to 6. Damn it.
It's not just solving triangles. Are you? Do you know how a fast Fourier transform works?
No, go on. Explain.
Okay, sine and cosine are used in that. No triangles at all. Do you know how discrete cosine transforms?
But you see, we're talking about celestial navigation, which specifically works with trigonomic function of Sekatoa.
Well, it does. Oh well, just show the process. Go ahead.
Let me quickly get on screen. Can I
Not
share my
open
screen?
to SketchUp models.
Okay. Let's just share my screen like that. Share. Okay. You can see what's going on here? Okay, I don't need this one yet. This is just the principle of 6. I want to bring that up just now. Okay. Navigation of the stars. Okay, this is obviously different techniques. Talking about trigonometric was first used in navigation by 14th century. Several navigation techniques can be identified. Navigation.
Oh, the cherry picking has begun.
Its personal notebooks, including the table of the application of plane trigonometry. You would agree plane trigonometry requires it to be a triangle.
No.
The application of plane trigonometry. You would agree plane trigonometry requires it to be a triangle.
No.
What's plane trigonometry?
Don't know that it's not specifying it here. It's just giving a little bit of
Plane trigonometry
overview.
requires it to be on the same plane, in other words. So if I'm
As I said last stream and many other times, Earth isn't flat because dictionary.
making an angle measurement over a plane,
Okay.
We can also use the Pythagorean theorem to find the distance between any 2 points on a Cartesian coordinate plane. Let's pick 2 points, the first
Cartesian,
with coordinates
of
x1,
course.
y1, and a second with coordinates x2, y2. But when we draw horizontal and vertical lines through the points, you can probably see where we're going. Since the new lines are perpendicular, the triangle is a right triangle, and we can apply the Pythagorean theorem.
Well,
It's
bring up
horizontal.
the process.
Okay.
Let's look at the process.
this is
they
one
used.
navigation by the stars.
Bring it up.
Trigonometry.
Yeah, bring it up.
One,
Bring
I'm
up
bringing
the,
next.
bring up.
Bring it up.
No, bring up
Don't
the
worry, we're
process
still
that they
getting
used
there.
in
We're
that.
still getting
Wait,
there.
You're a little. Why are you scared to bring up the process that they
We're
used?
still getting there. trigonometry
You're
processes.
you're just cherry picking. You're proving me right by cherry picking.
Trigonometry process or celestial navigation or astronavigation subject to presentation of maths curriculum, blah, blah, blah.
Bring it up. Let's look at how it's done.
I'm just first giving all the citations showing that they do use trigonometry.
Yeah, I really don't think Ficazoid had a slightest clue about what he's talking about. Just, again, cherry picking something out of his bottom hole.
Well, just show how it's done there, Flatzoid.
Trigonometry.
Let's look at how they do it. Why don't you want to show how it's done?
Sailing with trigonometry. Okay?
Let's bring it up. Come on. Oh,
I've got it up.
Bring it up.
Trigonometry is used in navigation.
No, bring up the process. Bring up the process. Let's look at the process. And
you saying we don't use trigonometry. I'm saying we do use trigonometry. That's the argument right now.
I'm happy to.
Yeah. As MC Toon says, bring up the process about how it's done. I thought I had made a model in SketchUp, but I seems I hadn't. So let's do this just for the fun of it. If we have the flat Earth, let's throw some grass on it. There. Yeah. And this guy with his 1.7 meter eye level. That's this guy's eye level. So when he have something, it's not easy to make spheres all of a sudden, so I'm just going to make a small square or a box. Like that. And that would be a star. Now, in order to have any kind of celestial navigation on this on the flat Earth, you need to know how high up that star is, because if you only have the angle, let's just put it there. If you're just measuring that angle towards that star and you have no idea how high up it is, you can't get its so important GP. There. And when you have that GP, you have to draw that equilateral, or what you call circle around it. So if you don't have the height of that star, you can't draw that circle because you have no idea how high up it is. So triangulation doesn't work. Angles are for chumps, yeah, or is it Bev who says you can't do fuck all with an angle? Well, yeah, you have a bit more than an angle, that's the point. You have the position of the GP and all of that. I can't do celestial navigation, but you do have a bit more than an angle. Oof, yeah, cubic stars require a container. That is, that's the container. Nope.
Go through the process in this book where there are no triangles involved. But you're saying there's triangles.
Sextant. There is also, I can just gonna pop up there again. There's one. And Why does it pop up there? SketchUp. That was the 3000. There. So, thing is, on a flat Earth, you can't have just a sextant. You have to know again how high up it is, because if it's a 3000 mile, the angles here are just have to be different than if the stars are 5,000 miles up. Didn't I change? Yeah. So here they are a bit closer together or further away. So you have the 40 here, but on the 5,000 one, you have the 31 here. Because if you want to have a different angle to a different elevation star, it just can't do that. So what elevation are the stars? Doesn't work.
Involved in the process, but you're not showing the process. Go ahead, show it where it's happening. You're not showing the process. Go ahead, show it where it's happening.
They sign and
Can you show this? Show the step-by-step process of celestial navigation using triangles. Go ahead.
Let's first start with a little bit of back.
So this is on, of course, on Faketsoid channel, and he's gonna skip over everything that he can't answer, I guess.
Background about lines of position in general and what they mean. When we talk about a line of position, we're just talking about some place on the Earth that we know we are, or more specifically, where we were. Imagine a case in which you're floating out there on the ocean and you have a lighthouse on an island, and you want to help figure out where you are using that lighthouse.
Why does it do that with
Celestially,
the voice?
a bearing is known as an azimuth. So we'll come back to that
Is Faketsoid playing it slower or something?
later. But if I use my compass and I take a bearing of that lighthouse, I could then go onto the chart and draw a line kind of backwards from the lighthouse, and I know I'm somewhere on that line. And when we do celestial navigation, we're going to do the same thing, but we're going to do it for not the lighthouses on Earth, but the lighthouses in the sky. For terrestrial or land or water, Earth-based navigation would be using geometry to help figure something out. Because if you knew the height of this light,
Yeah,
and
you
they're
know,
always
you know that.
listed on the chart, and you had some tool to help you measure the angle between the bottom and the top of that light,
Maybe
you
it's
can
excellent.
create a little triangle here. And it's a right triangle. You could create a little triangle here, and it's a right triangle. It's a right angle.
That is flat Earth triangulation. That has nothing to do with navigation. It's just a point with the height on it. So yeah,
Assuming the lighthouse is built straight, of course. So if you could measure this angle right here, call it maybe theta, that's like a mathematical angle, and you knew this angle right here, and that means you can figure out this angle right here.
just by knowing the distance, yeah. This is simple geometry.
And if you knew the height, and you can figure out your distance using that method. So we
Yeah, of course, the other way around, yeah. If you know that angle, you can also figure out the distance, yeah.
don't often do that in navigation because we've got radar and we've got charts and we've got compasses that give us lines of position, which are easier. But this is a valid technique. And when you think about celestial navigation, we're not necessarily doing that. But the principle of triangles and angles and right angles and figuring out sides and everything is definitely helpful when it comes to a celestial site reduction process.
They sign it.
Celestial side direction. I don't know if you can, again, I'm no expert in celestial navigation, but I don't think those two go past each other.
Can you show the step-by-step process of celestial navigation using triangles? Go ahead.
We could do the same thing.
Yeah, real sickness, big cherry picking.
We could set up, an angle between us, the horizon, and the sun, and it's going to turn into a big triangle that we could solve geometrically.
They sign and
Can you show this?
Still has nothing to do with navigation. It's just figuring out the height of something.
Show the step-by-step process of celestial navigation using triangles. Go ahead.
The horizon and the sun, and it's going to turn into a big triangle that we could solve geometrically. A big triangle that we could solve geometrically.
Yeah.
A big triangle that we could solve geometrically.
Okay, you take a measurement to the celestial object, correct?
Go ahead.
An angular measurement. I'm going
You
to
don't,
try
you
to
don't,
draw.
you don't need to keep.
I think I'm
you don't
gonna
have to
draw
keep
it.
asking me. Just go ahead and show the
I'm going
process
to-
of doing
I'm
celestial
going
navigation.
I need you to concede when I do these things. That's why.
I needed to concede. Listen to the master. He's so full of himself. So full of himself. Oh dear. It's painful already. We're 7 minutes in. This is soon to be over. Yeah. Damn.
Doing it this way.
No.
Yes, yeah. Okay. When we take a angular measurement to a star, let's say in the sky here, we are on the ocean floor or, on a ship or whatever, it doesn't matter. We're using a nautical sextant, so obviously on a little boat.
Yeah, make sure it's a nautical sextant. Yeah. For those of you who don't speak Norwegian there, what Bjørn said, pærhode, pearhead, I think is a bit, I don't know it more in Norwegian, but yeah, pearhead. He's a bit on top of, høy på pæra, he's a bit on top of himself.
Okay. And we're going to take an
Arrogant, yeah.
angular reading to the star, correct?
Inside there.
Would you agree about that?
Keep going.
Okay. Now we've got 2 straight lines going out that way. You would agree that we have a 90 degree.
No,
We don't
that's
have a
not 90. That's less than 90.
We don't have a 90.
That's not 90 there. No, that's less than 90.
That's not
maybe-
90. That's not 90.
Oh, there it is. Okay, now it's 90.
we
yeah,
have a 90.
between-
Okay.
You can't show that one and say, we have a 90.
That's less than 90.
You would agree that we have a 90 degree.
No. Just as Toon says, there's no 90 there.
No,
We don't
that's
have a
not 90. That's less.
No.
That's less than 90.
We don't have a 90.
No.
That's not 90 there. No, that's less than 90.
That's not
maybe-
90. That's not 90.
Oh, there
Yeah, but what do you use that for in navigation?
it is. Okay, now it's 90.
we
yeah,
have a 90.
between-
Okay. Okay, cool.
Yeah, at that point. Yeah.
Great. And the star has a 90 as well, correct?
That's it. That's presuming. What you're doing is presuming that the Earth is flat.
That's how it's
You're making an
working.
assumption.
No,
You're
this
making an
is-
assumption on this.
This is how the trigonometry works, mate.
That's it. That's presuming. What you're doing is presuming that the Earth is
that's
flat.
Yeah. So why would you need to draw that line in? That line has nothing to do there. That's a waste of, if it was ink, yeah, but
that's how it's
You're making
working.
an assumption.
No,
You're
this is-
making an assumption on this.
This is how the trigonometry works, mate.
Bodies whose geographic positions will be hundreds.
yeah, this is a bit different. This 90 is to the GP. You don't have a 90 anywhere here. So, sorry if you get side.
Or even thousands of miles away from your own position. Theoretically, you could use the first method to plot your line of position.
So you say,
it's-
but you.
Again, one of these flat earth laws of MC Toon. Every citation contradicts the flat earth claim.
But this is just your
Let's-
claim. You're not actually showing the process of
let's-
celestial navigation
let's say-
from a citation that you brought up. You're
let's
just
say-
you're just inventing this process that is not based on the books that you were referencing.
I see star A, let's say, at 50 degrees above the horizon. Now, how would I get that measurement? Okay. So
Sextant.
the way I would get that measurement is using a nautical instrument. You probably seen it. I'm gonna try to sketch it real quick. It's called a sextant, and I go to this book and I'm saying, okay, it's 6 p.m. and I'm looking at star A, and the book will tell me, well, star A should be located at this position, okay, at 6 p.m. Okay, at 6 p.m. you should be seeing star A directly over your head, 90 degrees, right? So if I'm
You're not drawing a a quarter circle on a 90. You're using that 90-degree angle on a 90.
standing out here in the middle of the ocean at this position, okay, not where I'm at, okay, at this particular position, I would see star A directly above my head at 90 degrees. So with those two pieces of information, okay, I can use some trigonometry. Okay, this is going to be a right angle. I have a degree here. I have a location here. Well, the only way you can do that is that you have to be a certain distance away from its location at 6 p.m.
Yeah,
Okay.
but you don't know how far that is on a flat Earth if you don't know the elevation of star A.
And it's basically going to build us a little circle here. So let's just make a number up. Let's say in order to see star A at 50 degrees, okay, at 6 p.m. at night, you have to be 900 miles away to be able to see that observation.
How the hell did they come to that conclusion? Where did 900 miles come from? I'm going to find that here. I have a paint drawing. I'm going to make extra large icons. Show extra large. After 7 years of collecting bullshit, my folder is thick. I thought I knew where I had it. Oh well. Let's use, as Figazzo does, paint. Tum tum ta. Like that. That's the Earth. The Earth is green. Oh, look at my drawing. There's a sextant thingy, right? So if the angle up there is whatever degrees, and you have that one, either there, or there. Same angle, but what's the distance? Nobody knows. If you are seeing most stars in the screen, it's black. Yeah, that's from other reasons inside there. So yeah, you most definitely need to know how high up these stars are to know the distance. Again, simple geometry. Nope.
To be 900 miles away.
I would like to see the math on that, because now you can figure out the height of star A just using this. Let's try that. Sure, let's try that. So 900 miles. It's 900 meters. Oops. I missed that one. Like that. And the angle was 50. So let's tilt it by 50. And of course a 90. So, where? No. Wrong one. Where these two meet, that will be the elevation of that star. Away with that. So that star is about 1,000 kilometers up. Problem solved. So yeah. Thousands. You did that on the calculator. I use metric. So yeah. It's the same, of course. The numbers are the same. There's just a different. Yeah, 1072. Ta-da! I don't do let's see, like that. I have no idea how to do that on a calculator with this I don't know what it is, tangents and all of sinus, and yeah, I can't do that with the triangles, so I do it this way. But it works. It works every time.
To be able to see that observation.
Let's say I measured an angle to the star at 50 degrees.
Yeah, had it been 45 degrees, the distance would be the same as the height would be the same as the distance. Triangle calculator on, yeah. Cheater.
Okay? You would agree that's 50 degrees. Okay, to the star.
Not to scale, that's fine.
But yeah, it's not to scale, obviously. Okay?
Yeah.
We measured 50. What's the internal sum of a triangle? 180.
180.
So that would give us 40, correct?
Yeah.
Okay, so if we use the math anyway to just verify this, 90 minus the measured angle gives us the altitude, the elevation angle, which is 40, times 60 nautical miles, which gives us our distance. So the altitude, the elevation angle, which is 40, times 60 nautical miles, which gives us our distance.
How the crap does that work?
Minus the measured angle gives us the altitude, the elevation angle, which is 40, times 60 nautical miles, which gives us our distance.
Sorry guys, but I'm a bit lost now. How did that happen? Seriously. So, because that angle between these two are 40, that distance is 600. I think I missed something there. I'm confused, guys. How the hell can you get to that conclusion just, You need to know the height of that star. The point up here. You need to know the height for this to work. Which that thing, yeah. Either way, when he figure out the distance and the angles, he sure as hell know the altitude of the stars. So he needs to use that same altitude every single time he uses flat Earth trigonometry, anything. Yeah, we now know the altitude of the stars on his map, world, model, whatever. We're off to a bad start here, guys. That hurt. Oh dear. That was the end of that one. Thank heavens. I mean, he's setting the standard for being stupid, dumb, whatever. Let's see if the email has something new. Nope, still no flat earthers. This is... Yeah. I'm going to push it more during the following days, I think. Just throwing some short videos out there and, as I had on my thumbnail, just acting smug about it. Just kick a bit ass and be obnoxious. So I'm not usually that person, but if that's what draws them, it's like you pull more flies with vinegar than with honey or something. So let's try. I know it was the wrong way around, but I usually the one who use honey, not vinegar. Holy smoke. I need a drink. I'm gonna... Those bottles make a hell of a lot of sound when you crunch them. Oh dear. So I lined up the next one, and I'm not sure if this is going to get anything better or worse. You probably can judge by yourself by now. Simon Dan doesn't get a level. Well, I forgot. I prepared this one. This is the ship that goes between Norway and Denmark. So I guess both Bjørn and Insider knows about this ship, the Color Line Cruise. So if a guy stands here, oh, this wasn't the right one. Oh, never mind. And you have what the flat earthers call a flat baseline. That's not flat at all, because it's just a flat line going from the observer to the horizon. So even though the Earth is curved, the baseline isn't the Earth, it's the observer. And then you have the GP and everything, so yeah. That's the dip correction. 0.169 degrees, that's a dip correction to the horizon from horizontal to the dip. And you have to have dip correction. I had made another one that's a bit more detailed, but I don't know where it is. Yeah. Let's break out the next one. This is so stupid.
The continuation of Flatzoid's response to Professor Dave.
That wasn't yesterday. Seems like a bit younger. He has a new office, of course, but yeah. High-tech opening. Yeah. yeah. Don't screech on that, please. Looks like something from Men in Black.
We had just finished the argument from Professor Dave that flat earthers always use the 8 inches per mile squared.
And you cannot see it. The orange line and the green line line up so perfect that you can't even see it. So if you're not happy that 1,000 miles is still a short distance in your book, take a look here. I've taken it all the way out to 7,900 miles. It's off by 0.03%.
And we move on to how they always say that water is always level.
You may already have guessed that what we're looking at here is a water level. This technology, if not quite the plastic, goes back to the ancient Greeks, the Romans, the Egyptians. They all used water to level their buildings out.
Yeah.
Not only can it measure levels over long distances, you could do it over half a mile if you wanted to, but also you can measure around corners. See that once you get the air out of it, just give the hoses a little bit of...
Once again, Catsoid is doing something with that voice. Lower it. Why the hell does it do that? Is it to get around some copy strike or something? I don't know, but this is weird.
a shake, make sure there's no trapped air in there, and you can see that the water finds its own level. Water finds its own level.
So, sorry guys. Is it that one? That one. Which one did I use again? That one. Also, when I had this there, I showed it to Bev, Try Thinking, and they said that this here you can't establish a horizontal with this one because the horizon is too far away. Even that's what exactly the same that they are doing. Somehow they're establishing a horizontal. So if they're using it for whatever, I don't know, but this one is somehow not okay because reasons. But yeah, water always finds its level. I had some plans to go back there to do another observation, but things have happened, so I just can't for a while. But yeah, water seeks its own level. We know that.
Finds its own level.
Here we go.
This guy's failing miserably.
All flat earthers say the same two things about water. The first is water doesn't curve. And the second is water finds its own level.
Water at rest is level. So water finds its own level is true. Just like when you go to a lake and it's at rest, it's level. Look at that. Is that curving to you? No, water does not curve. It's level.
Flat.
So it's a matter of Earth is flat because stationary again.
So they're doing
the horizon is too far away. You have to stick it half in water half. Yeah, I have shown that before, I think. There. That's the only time you can use 8 inches per mile square. That's the only time.
Classic Fleur thing of always confusing level with flat.
Level.
That face there.
It's confusing level with flat.
Yeah, water level, yeah. Sure. I get it. He is the king of smug faces.
Level. The same height at all places, parallel to a flat ground.
Flat. No. If you're living in a high-rise or a skyscraper, a level is the level you live on. If you're in education or in school, it's the level of your education. If we're talking about sound, it's the sound level, decibels. A level playing field, if you're going to have a race for something and you need to climb that tree, of course the elephant has nothing to do there, so not a level playing field. If you're playing a game, what level are you on? If you're talking about tools, a level, that's a level that shows you what horizontal is. If you're at the doctor's, you have the cholesterol level in your blood. If you're talking about the earth, then level is a curved line. So pick your topic before you decide what level is. So yeah, what level are you talking about? Scatsoid.
At the same height as some reference constructed as level with.
Look
and
at
varied
that
in
smart face.
frequency.
You just can't stop it.
L P Z P L.
Level. This is called physics. That's why they have water levels when they.
Yeah, water doesn't behave as in a dictionary.
Do construction of big buildings. Sometimes they even create their own little water level of like 100 meters or something, literally from the ground, and fill it with water so they can have a level of 100.
Yeah, Slice Barkane, for those of you who don't know that is, he was, when I got to the circus about 7 years ago, he was one of the OG ones, together with Red Sartoric and Sean Hufford, Stoundley, and some other guys, 82 Productions. And I'm sorry about that German guy, I don't remember his name, there was one more. He moved to Denmark, yeah, sorry about names. But this was old 7 years ago.
Meters when doing construction. Why is this, Dave?
Probably because over 100 metres, the curve of the massive Earth in comparison is negligible.
Yeah. Slice Barkane had an experiment in Bug, in BUG, Bug, in Geostreber, Tuck, where you had, I think he had 1,500 meter long tube with many tubes sticking up. Unfortunately, had a leak on it, so it wasn't perfect. But that was exactly to measure, when all of these water tubes, to measure the curved line in those tubes. But it didn't go well, and he hasn't done the repeat yet. He had planned for it, but COVID happened, and his life happened, and something else. So hopefully he will do it again. But yeah, that showed that all the tubes made a curve. Where did the sound go?
Is negligible.
Yeah, of course you have much curvature on a small area. Why this?
Is it because the water curves, or is it because water finds its own level?
Both. It curves and it finds its own level. Level is a curved line.
Well, it does do both, to be fair, depending on the distances involved. Over 100 metres, you won't detect the curve, but...
I think 8 centimeters on 100 meters isn't quite right. You have 8 inches per mile. Yeah, probably. Yeah. Okay. Probably. sextant to line of position, a complete sight reduction from an offshore sailing race. Okay. Do you need to be a moderator in order to find a link or something? If you have a link, you are now blue. Thank you.
Over 100 miles, you will.
Yeah.
You know, this does also fall under...
Sorry.
Over 100 miles, you will.
You know, this does also fall under relative density.
He is kind of cute though.
Disequilibrium.
Oh no, not that one again. We've done that one to death, Flatsoid.
The second phrase is completely meaningless, so the fact that you all say that exact thing verbatim is just...
Oh, so this is me reacting to Katsoy, who's reacting to Simon Dan and or Professor, yeah.
Just one of the many
He's a smuggle hole, yeah.
Demonstrations that you all blindly repeat what you hear without giving it a moment's thought.
Spot on, Dave, and this has been proved
Meaningless, so the fact that you all say that exact thing verbatim is just one of the many demonstrations that you all blindly repeat what you hear without giving it a moment's thought.
Spot on, Dave, and this has been proved time and time and time again. Every time you hear a flat earther say that there cannot be an atmosphere without a container.
System insulated from the outside world, and we have two...
Again with this voice. With this voice. That was the V and W switched around. Sorry.
bulbs. And there's a valve between them. And so we have gas and we have vacuum. So the Joule free expansion.
Yes, it's a react inception, I guess. But I'm so tired of flat earthers wanting to have this experiment, and I'm going to pull out my my SketchUp. Because of course I have made a model of this. There. He's drawing this, and all the flat earthers will have, just going to check the height of that one. So I'm not getting too big letters. 4 millimeters, wow. If you ask a flat earther what he want to have in there, look here, if I put it as 75 meters, that would be a bit too much. Like that. They want to have 14.7 psi. Because that's, for some reason, I don't know, but they want to have this next to that without checking that Pikes Peak is 9.1 and Mount Everest is 4.9. Mr. Sensible's Mage 2 went up to 38,000 meters, and that was 0.003% of the atmosphere. Of course, that, yeah. So why the hell do they want to have 14.7 next to nothing? I really don't get it. Yeah. Fkat's law of entropy. I need to frame that, I think. Why do they want to have this? I don't get it.
Involves opening this valve and asking what happens
when this gas moves into the other
Stop
bulb
doing that with a
or
voice,
distributes
fat
between
cat,
the
sorry.
two. Well, since the gas
Let
is
them have their
expanding
normal voice.
into vacuum, no work is done. Since it's isolated, no heat is added.
As for the first phrase, stating that water doesn't curve is at least a coherent.
I'm confused again, guys. We're talking about water finding its own level, and all of a sudden it has gas pressure thingy, and back to water level. Why? Copyright protection could be, but that's also, I think, some other things you can pick up. I don't know, but yeah, could be. But again, why all that about gas pressure? Nothing to do with the water finding its own level.
Thought. How?
Okay, first of all, problem. Telling us the second part of the statement is not relevant and it doesn't mean anything. It's the same statement as water doesn't curve, because level does not curve, Dave.
Yeah, level curves, and also, as you have seen before, water curves. So yeah, been there, done that. You know this, guys.
It's no part higher than the other.
Well, actually, level does curve.
As water doesn't curve, because level does not curve, Dave. It's no part higher than the other.
Yeah. So if I hold my finger just at one point here and I spin that around, there's no point higher than the other around that globe. Every single point is the same distance away from the center of the sphere. No part higher than the other. Damn.
Well, actually, level does curve.
Yeah, this is a classic.
Level
Star Trek.
definition. Having a flat horizontal surface. Give a flat and even surface.
There. Boom. Definition of level. Yeah, so he's going just off the first one here, of course. And if he can cherry pick, so can we. Having no part higher than the earth, conforming to the curvature of the liquid parts of the Earth's surface. Forget soil. Talking about the Earth, you should use the one that is about the Earth. This one is talking about the Earth. The curvature of the liquid part of the Earth's surface. So yeah, cherry pick as much as you want, but this is the one that actually says something about the Earth. Nothing here is about the Earth. We're talking about the Earth, and that's down here. Wow.
The same height as someone or something else. Since when does horizontal or flat curve? Let's go look what flat definition is. Flat. Having a level surface.
Yeah. As I showed earlier in that level part in the high riser, you can also live in a flat. If you have an apartment, it's a flat. So your tire can be flat, even though it's not flat. So, yeah. Earth is
without raised areas, or indentations into our horizontal position.
Maybe I should start having my mic here. Does that look better? I think I have about the same size mic as a big ass Blue Yeti. But no, I like to have one out of the frame. There. You don't need to show off. Hej Björn, ha en god natt. Så gott.
The flat part of
Takk for møtet opp.
something. No curve.
That was just me saying goodnight to Björn here.
Our horizontal position. The flat part of something. No curve. Let's see what's horizontal. A parallel to the plane of the horizon. So horizon is horizontal, guys.
What the crap?
Part of something. No curve.
No curve. If there had been a competition being smug, he would win.
Let's see what's horizontal. A parallel to the plane of the horizon. So horizon is horizontal, guys.
No, it's not. I actually don't know why it says that at all. Because parallel to the plane of the horizon. Nope. A plane. Could a plane be curved? A curved plane? Yes, indeed.
At right angles to the vertical.
Yeah. You have the vertical goes around and you can have a plane following that. A curved plane, not a flat plane.
Ouch, you know, elevation angles. A horizontal line or plane.
This hurts.
Being involved in the same level. No curve.
If something is always a certain level above water, let's say for example a piece of rope, then after a while that rope will begin to curve. It will curve yet remain the exact same height above the water.
What we have here, Dan?
That was actually kind of cute, but wrong place, Forgetside. You're wrong.
Is ropes. Now you say they would be curving with the earth. Now,
no, Simon Dan didn't say as it was curved with gravity. He used to say just having a certain elevation above it, following the curvature, not hanging down like this one. But that rope, and that board are level with each other.
Tell me something.
Curved lines can be parallel, right? So they are also parallel with each other.
Which direction are these ropes curving? As far as I know, a sphere would require to curve up.
I sense a smug face coming in. There it is.
This is going in the opposite direction.
Yeah, you just know it. Smug face incoming.
Must I go and get a definition for level now as well? Level, a horizontal plane, or line with respect to the distance above or below the given point.
And he just debunked himself right there. A line with respect to the distance above or below a given point.
Yeah, a given point around the globe. A horizontal plane or line.
The exact example I just gave a minute ago.
Does a horizontal line curve, Professor? No. Having a flat horizontal surface, Professor Dave.
But again, Forgetside, use the right definition where it actually says something about the Earth.
Okay? So, when you state things like it doesn't curve, it's water finds its own level, you are stating the water from point A to point B is a horizontal plane. Okay, just had to point that out.
Yeah. Just had to point that out. Listen to the expert.
However, it is dead wrong. Put a drop of water on a piece of wax.
This
Maybe I should have my camera up there.
little droplet have what you call surface tension.
Yes, but it does debunk the point that water doesn't curve. It doesn't say large bodies of water don't curve, it says water does not curve. These photos clearly show otherwise, regardless of the explanation.
So, no matter the explanation, Dan, you do know that just shows you to be biased towards the argument. And just because you guys leave out finds its level or large bodies of water is just you being dishonest. Remember, Dave wrote there, water does. And just because you guys leave out finds its level or large bodies of water.
No, we don't leave out large bodies of water. Large bodies of water curves. You numbnut.
Is just you being dishonest. Remember, Dave wrote there, water doesn't curve. Not flat earthers say this. We've all said, water seeks its level when at rest.
Nobody denies that. We all agree that water finds its level.
Water tension, aka water droplet, is not a large body at rest. There's little fine particles and dust and stuff holding onto it. It's holding it. It's like having a group of people holding hands together. You are linked together and you create a circle. It's simply that. It's all the air pressure. Remember, Heinz? Air pressure is greater than that little droplet with the little dust particles on it, which is giving it water tension.
Probably the worst explanation for surface tension I have ever heard.
Hence why it's that way. Now, if you had to add another droplet to it, see, it's already starting to what? Find its own level. The more water you add to it, the more pressure it creates. The more it's going to get level. That's why hence it finds its own level. Keyword here, find, Professor. Well, not Professor, Dave.
Wax paper or...
Yes, he is a professor because he was a teacher at the... I think it was on the university. And when you are a teacher at the university, you can call yourself a professor. There are so many other people around this community on both sides that have just nicknames that them call themselves something. Doctor something, or yeah, deal with it. It's a part of the game. But he actually is a professor.
Or a leaf. What does it look like? A freaking sphere.
This is the type of arguments you get from these guys. This is it. I haven't really seen any... How can I put it? I haven't seen anything of value from this guy presented, and we're number 3 already.
Of course you haven't, because you deny everything. I haven't seen anything of value from any flat earthers during the last 7 years. Same shit.
Well, how about this? This is a blob of water in the...
I was thinking about that. I thought I should search it up on YouTube and show it, but yeah, Simon Dan already did.
International Space Station. Now, of course, this is also water tension, but crucially, why does it have that spherical shape? Why not rectangular or a flat shape?
Your device over the target image and your rocket or spacecraft.
Now he takes the voice in a different direction, like Smurf or something. Not nice, Flatside. Sorry, Cat-side.
Will appear in 3D.
Think about that, Flatside.
This is a guy that calls himself a...
What?
Your device over the target image and your rocket or spacecraft will appear in 3D.
Yeah. I done this myself with my phone on my living room table, just showing off something on the table. That drop was real, not CGI.
Think about
Denial.
that, Flatsoid.
This is a guy that calls himself a professor, for Pete's sake. And he can't even bring up an argument that brings any logic and value to it.
It had plenty of value and logic, but you just can't grasp the argument as usual, matey.
It's insane.
Isn't that something? In your haste to mindlessly parrot what you heard from flat earth priests about water, you forgot to look at water.
Yeah.
Again.
Good one.
Dave. Air pressure around it. Little dust particles. It's called water tension. It's a droplet of water, Dave.
Air pressure.
I'm not sure
above
what's
it.
funnier, the fact that Flatsoid doesn't understand Dave's argument, or that he thinks surface tension is caused by dust. Flatsoid doesn't understand Dave's argument, or that he thinks surface tension is caused by dust.
Flatsoid doesn't understand! Exclamation point.
Actually, no, it's got to do with intermolecular bonds.
And now, for some reason, we have the camera, what do you call it again? Shadow plate, or what do you call it? Yeah, on his stream. Because it makes him look like more important or something, I don't know. ISO 800, you can pull that down because there's a whole lot of light around you. You can probably go to 400, 640, 400, 5, not 800.
But I'm simply saying surface tension with dust and particles, so you would have an understanding where the surface is. That's about it. When do you take a water droplet and measure your level with the water droplet?
Water curves, my friends.
Okay.
That laughter. Oh.
Water curves, guys, because of water tension of a droplet, guys. This is how water curves.
But it does. It's on the screen right there. I'm not sure why you're laughing.
Why am I laughing? Because you guys think water tension.
And now that shadow plate disappeared. Because reasons.
Which causes a droplet, therefore means curved water. No, this simply means the droplet is taking the shape of what's containing it. In this case, the intermolecular bonds with all the particles and things and the air pressure. Show me an ocean curving, please.
Now,
Tum tum ta.
that's a different question, Flatsoid. Here you go, by the way.
No. Because that's fake. And probably with a fisheye lens. But then again, those lines here would be a lot more curved if that was the case.
Look at this curved meniscus.
Yeah, that's why when I started doing this for the first time, I got there. One. The first time I was at the end of the world, I had my water tube, but I got a hell of a lot of yelling because the tubes I used was too thin, so the meniscus was too curved. I didn't bring it the first time. Second time. There we go. The first time I had just the tubes, and of course then the meniscus was a too big part of the water inside. So after that, when I was started using this that one, a much bigger one, then meniscus doesn't play that big part.
Look at these waves.
Do you see how he has to go past it really quickly? Oh man, I hope I can get into it quickly. Curved meniscus. What is this container it is in? What is going on? Is it not having some tension on the sides, hence it seems to be curving?
A meniscus is more to do with water's adhesion than surface tension alone, Flatzoid.
Curved in the upper part, yeah.
And why is it curving the wrong way, Dave?
Why is this the wrong way? It's, as you said, it's sticking to the sides. It's the friction and the stickiness and all of that. That's not the wrong way. It would be strange if it was the other way.
Maybe that's why you had to quickly just poop.
It's like when you have these capillary tubes. You have one in the bigger tube in the bottom, and you have thinner and thinner tubes. And the last one is a capillary tube or something. It's the same name as the blood vessels in the fingers. Capillary tube, yeah. And the thinner they are, the higher up the water climbs because of all of that. So is that water sticking us level? Is on level? I don't know. There.
Pass it by for the people.
Again, you're missing the point here. You say that water doesn't curve, and Dave is just showing examples where it does.
Is anyone here a doctor?
This curved meniscus. Look.
A curved wave. It's a moving water. Water finds its own level at rest. That's why you don't have the word rest in here. Is that why? So that's kind of
my observation was water in rest.
Dishonest, don't you think?
No, I don't, because it doesn't say water finds its own level at rest, does it?
Because I'm not going to say you're too dumb to know it's rest, because at least you have an IQ 1 greater than Sean Hawkins, so...
But...
own level at rest, does it?
Because I'm not going to say you're too dumb to know it's rest, because at least you have an IQ 1 greater than Sean Hawkins, so you...
If you're the one talking about IQ, now I know he isn't the worst, most expensive luggage, but I don't know what IQ Ficazzo is claiming, but yeah, oh, his name again. Again, I struggle a lot with names, and that it's a real pain, but the one who went to Antarctica, oof. It's like you have dyslexia with words and you have dyscalculia with numbers. I had names. It just blanks out. Yeah, either way, I would like to know his IQ.
Do know it at rest, but you're going to leave that out. You know, because it's moving, that means it's not at rest. Dave?
Look at these waves. Water curves all the time. Water is not magic. It is subject to influence by...
Austin Whitsitt, he claimed an IQ of 160. Wasn't that the same as Einstein?
External forces.
Yeah, like air pressure, containment, temperature change, phase changes. Yeah, that's why they say at rest. Water lies level at rest.
Flat earthers trying to be scientists is just the funniest thing, isn't it?
The ad hominem attack. Ad hominem criticism is where...
Again, the voice, but no, that's not ad hominem, that's just making fun of.
Instead of criticizing the argument or ideas of the person with whom you are conversing, you criticize the person themselves.
It seeks its own level. So when it seeks its own level and it becomes at rest, it lays perfectly level, flat,
yeah.
horizontal.
No.
Comes at rest, it lays perfectly level.
And stop there. Then we agree. Perfectly level. Which is not the same thing as flat or horizontal when you're talking about the definition of level according to the Earth.
Flat, horizontal, plane.
Just like all other matter. With a spherical water droplet, that's the electromagnetic force. Water molecules make hydrogen bonds with one another, which in this context we refer to as cohesive forces. That's why water has a very high surface tension. And
he just debunked himself, guys.
No, he's just explaining to you because you're dumb.
Thank you so much for watching. It truly is appreciated. If you enjoyed it, please do consider subscribing to the channel. And if you really, really enjoyed it, hit that like button too.
Yeah, Earth is flat because dictionary. Let's check the email again and see if any flat earthers have sent in a mail. No, they haven't. I'm going to show you in a second here, but the thumbnail for the next one, which will be the last one. We've gone to 1 hour and 20 minutes now, and this one is 11, almost 12 minutes long, so I guess if this stream goes about 2 hours, I think that will be enough for today. And as I said, I will go on during the week and probably post some just, not short videos, but shorter, some snippets or maybe some short, yeah, I don't know, but I need to kick some flat earth ass soon. But yeah, the thumbnail for the last one here, it's freaking priceless. So as I said in my stream 2 days ago, that I have thought about making myself an avatar. As you probably see here, I lack anything of upper body shape. You saw it on a t-shirt, but I don't have any upper body strength or shape or anything. But I don't think Fakatsoid has those guns. Honestly, this is a bit over the edge, Fakatsoid. You're not Chuck Norris, sorry. I'm going. How about them guns, eh? Okay, let's start the last one. May the force be with me. So he is probably in his, I don't know what you call it, a workshop. He is a spray painter, so I guess this is something inside his workshop or whatever machine. It is flat, yeah, and by judging where the camera is, it's just about skimming the surface, as we showed earlier here. We are there. We are at that level. So whatever he's, I haven't seen this, but whatever he's going to show is from that eye level. Oh, we're going down below the top of, yeah. In that case, I actually need to prepare, just a second. YouTube, my channel. Oh, is FTFE live? Oh, no wonder I have 5 people watching. Craig is live. I didn't know that. Anywho, I'm going to continue either way. I'm going to watch him later. Videos. Because this was Mitchell from Australia a few years ago. Did exactly the same thing. There. Now I have that ready, so let's continue. Is this all? Yeah, that machine looks like it. The surface is quite flat, yeah. But why the hell does it lower the camera below the level of the... You can see here it starts to shade off because the distortion of the... Oof. Why do you bury your camera halfway down the ground? This has just a tiny bit of sound in case it's just talking. And a bolt. Yeah, he lowers the camera below the line of the table. Why? Nobody denies bottom-up obstructions when you bury your camera halfway down the ground. Oh. A bit more, a bit more. There. Let's go back a few frames. Right there. Why does it do that? Remember that intro? Wow.
Can do at home. You have a coin and a flat table.
Yeah.
And I'm going to demonstrate how we can make
5 years
an
ago.
object disappear bottom up.
So this is Mitchell from Australia doing the same thing. Having the camera below the table.
Without the need of curvature, or without the need of a physical obstruction for that matter. Now you Globers are going to sit...
So what I did, exactly the same thing, except I didn't move the coin, I had 2 coins. That camera is below the height of the table. There's no question about it. Second, this has... So now I use my digital zoom just into the table. It's nothing to do with there you can see whatsoever. And, the only thing I do is rotate the focus. No zoom,
this is
just focus.
Only focus. And as you saw, I focused onto the end of the table. Nothing to do with
From
zooming
there,
whatsoever.
Just focus in anything.
This is only focus. And as you saw, I focused onto the end of the table.
So, so easy to debunk. Is that everything it does?
All the screenshots I just took. Yeah, you can see I've placed a
My left ear is hearing, but not my right. So if you have mono on your left side, that's not me.
fine line tape on top of the bottom of the bolt. It has like a little lip on it. Size. First of all, obviously you have the original picture there. Yeah, if we look at information into a smaller, it looked like it's lost at
Yeah, everything here is white because you have covered everything with the bottom, sorry, the top of the table.
least half of its resolvability. It looks like it's gone below a certain curve, even the cap on the right.
it looks like you have your camera below this certain surface.
You can't see the reflection of the cap anymore on the surface.
Why should you? Try it in the mirror, same thing.
Because it's unresolvable. It has what we call has gone through the resolvability limit.
No. Because then you should move it twice as far and you wouldn't see it at all with your own eyes or the camera. It doesn't get too small to see because it's just 5 meters away. How shitty camera do you have, man?
It has diffracted limit.
No. You had covered it with the top of the table.
Has reached the diffracted limit. And the limitation, thanks to the larger angle of the surface, overrides the bottom of that object.
No, because you have the camera below the surface. You can see everything is white. You're cheating, just like I did to debunk Mitchell from Australia. When you have your camera, you have the lens of the camera just below halfway table. You can still see on top of it, but everything is like this, just a white fog.
As you can see, I put I've put a block here just to denote, to say that look how the bottom of that cap looks to be dissolved into the bottom of that surface. Note that this is still a flat surface, and
yeah, it's flat, but you have a camera below it.
There is no curve to it whatsoever.
Yeah, still you have the center of the camera is below the surface.
It's more resolvable a bit better now with the one that's closer. We can just see a tint of the reflection on the surface. Obviously, it's a bit more difficult because of the diffraction of it being so close to the surface that it makes that white shady tint. But we are still able to see the bottom of this closer and larger angular.
Why the hell does it need so long time to describe what's happening? Well, maybe because it's making stuff up as it goes, I presume. For those of us who doesn't need that, it's just you blocked it with the table.
Lid. Now, if you look at the bolt, obviously, like I was saying, it looks like about at least half of the bolt is underneath the curved surface.
Yeah, but as I also showed you here with my coin, that one you can see all the way to the bottom here. You can see the reflection in the table and everything, even though my camera is below it and I actually zoom into the end there. You can still see the coin and the reflection. The camera is below the center of the lens is below the surface of the table. Not just it's only just about a millimeter or two, but yeah, that's more than enough. You don't see the surface anymore. Hoo-wee.
But like I said again, it's not curved, it is a flat element.
Yeah, so was my living room table. It's flat.
Aluminium bar. And we can carry on looking. You can see the same thing. And as we carry on, we're raising it in different elevations just to show the differences. As you can see.
Yeah, that's not important. That's just
because I'm high enough now, you are able to resolve that whole bolt. You can see everything.
You can resolve the whole bolt because you can see it. If your camera is that shitty that you can't resolve it because you have moved it too far away or too low. If cameras are as bad as I need them to do, there wouldn't be any professional photographers. Sorry.
There you can see the masking tape even at the bottom here on this further away. There you can see the masking tape even at the bottom here on this further away lid.
It's the same distance because you moved the camera just up and down. It hasn't been any different to the distance. All you did was go below the surface of the table, so it was blocked, physically blocked.
And it also had seemed to raise the level of that back lid. You can see how it almost seems like it's in the same level. Thanks to the raising of eye level, the convergence zone would be around about...
The conversion zone.
Yeah. So everything above convergence zone goes in down to the, and everything below convergence zone goes up towards the convergence zone. So that's called perspective.
That's perspective, yes. But if we lower the camera so the center of the lens is below the surface of the table, that's cheating.
Just once again pointing out that you can see the reflection and you can see the bottoms. Same with that, and showing how it looks to have that angle which pushed out further, and because we have that bolt, we can more or less see the green if you look very nice. And we take it again. Now we even angle is limited, being very very close to the bottom of the surface. You cannot.
Yeah, actually, that's the closest you're allowed to get, because we never do any observations with our eyes halfway down in the ground.
Resolve that green fine line tape anymore. Why? Because of the diffraction limit and because the angle.
Because the diffraction limit. Blah, blah, blah. What is diffraction, the catsoid?
Is limited, being very low to the surface. You can see there's the horizon, and based on the horizon we can't see the bottom of the bolt, and we can't see the green fine line tape, so therefore it has bottom obstruction. And we take it again. Now we even based on the horizon we can't see the bottom of the bolt, and we can't see the green fine line tape, so therefore it has bottom obstruction.
Yeah, because your camera is so close to the surface.
And we take it again. Now we
when you get that white haze above the surface, your camera is too close.
Even a touch lower, and that's you see where this diffraction limit is showing even more, thanks to being very very close to the surface. Note we are still above.
It's 1 minute left. Just listening to his final conclusion, and that'll be it.
And the eye level is around about here, between these two. So
the eye line is right about here. No.
Very very close to the surface. Note we are still above, and the eye level is around about here.
You can't say that the eye line is right about here. You have no point of reference to go for, and you can't go, as you have the lens at the surface, your eye line is down here, not up there. It might seem like a tiny bit difference, but
between
seriously,
these two, so it's still above. As you can see, the reference for the bolt in front, the camera is above, around about there.
As long as you have the white haze in front of the camera, it's too low.
So it's above, and we cannot resolve the bottom of the furthest away lid because of diffraction, and the furthest away as well because the Aries disc is too much entwined that the surface closest to us, which is the larger angle, is being the most resolved, and the disc is too much entwined that the surface closest to us, which is the larger angle.
The surface closest to us is the largest angle. The last time I heard that, I think, was Gary Benga. How the actual fuck is a surface the largest angle? Where is the angle of a surface? It's a surface, not an angle. That's two completely different things. Also, if everything of this is the case, why is there bottom obstructions from 22 meters above the sea level? I don't have my camera halfway buried. I'm up there. And still, those turbines are standing on a 175 meter high hill, which I don't see. This here is just an island for the lighthouse. Those turbines are 68 kilometers away. And bottom obstruction from a higher altitude. That's what we need to see.
Is being the most resolved, and we can't resolve the further away angle. Just pointing that out again.
We can't resolve the further away angle. some dressing with that, please.
To show you. Okay, now we are very high above, as you can see.
No, that's not very high. That's normal. That's actually very normal, because when we do observations, we are actually above the surface. So we are closing into normal now.
And everything is resolvable. It's just plain and simple, showing again that the back seems to have raised higher than the front, all because of the angle. And yeah, plain and simple.
Yep. There you have it. Oh. He just debunked himself. When you're at a normal level, as in a few meters above something, nothing should be obstructed. If you have your eyes or your camera halfway buried in the ground, then you get bottom-up obstructions over a flat surface. Oh dear. Yeah, I saw the number of viewers drop here for a while, and we're down at 3 and 4, now it's 7. I didn't see that until I was going from my own video, and I saw that Craig was alive. Craig was live. Of course he's alive. So, yeah, 1 hour, 40 minutes, no flat earthers. I'm going to cut this here now so we can go over to see Craig. Thank you for watching, everyone who was here. Real Cygnus, you've been here for a while. Sturston. The handles appear to be different heights. Pity, yeah. That also. I'm not going to show back, but that handle on that one seems to be a bit lower than the hand on that one. So, of course he's doing some trickery. He can't be honest. Just can't be honest. So, yeah. We should end it there and go over and watch Craig, I guess. Again, thank you so much for being here. I really appreciate it. And hopefully I will do the same thing in a couple of weeks. During the meantime, I'm going to be a bit more smug and kick some more flat earth ass, I guess. I really want someone to come on. So, yeah. See you guys. Go over to Craig and watch him. Thank you so much for being here. See you next time. Bye-bye.